A analog oscillator, or aka multi-stable vibrator, utilizes cross-connected capacitors and transistors to create a oscillating current in the form of a square wavelength. This wavelength represents the high to low of the voltage in one of the transistors. A transistor is a solid-state switch, meaning it does not require any physical element to turn itself on and off. In this circuit, an NPN transistor is used. To further understand this type of transistor, I'll look at a small circuit I built that explains how it works. This circuit uses a transistor in its simplest and most pure form. As we can see, the light will only turn on when a small proportion of current is applied to the middle lead of the transistor. This lead is also referred to as the base pin. A PNP transistor works in the same way, except it is inverted, so when current is not applied to the middle pin, the transistor is saturated. Now that we have the basic understandings of a PNP and NPN transistor, we can apply it to the analog oscillator. Alright, now we can see the analog oscillator. As you can see, there are two lights flashing back and forth. These lights are flashing because there is a charge and discharge of current happening in the two 470 microfarad capacitors. One of the capacitors is charging current, while the other one is discharging current into its cross-coupled transistor. The current flows from the capacitor into the transistor's base pin. This saturates the transistor and allows current to flow through to ground. Now grounded, the LED is on, but only for a small proportion of time. You see, once the capacitor has finished discharging all of its current into the transistor, it begins charging, and there is no longer current feeding into the base pin of its cross-coupled transistor. Now, the other capacitor can discharge its current into its cross-coupled transistor. This charge and discharge of current between the two capacitors accounts for the flashing of the LEDs. Now, the LEDs used in the circuit aren't actually required. You see, the circuit will always have a stable and unstable balance of voltage between the two transistors. The potential for the circuit is far more than making lights flash. As you can see, we're creating a wavelength or a frequency, and this wavelength can be controlled by the amount of resistance or the amount of capacitance applied to this circuit. To show this, I've done something actually pretty cool. I've hooked up a speaker to one of the LEDs. By doing this, a beeping noise will be made anytime the transistor below it is saturated. To demonstrate how you can manipulate the square wave, I've put in place a 1000 microfarad capacitor. See if you can spot the difference. The parts used in the analog oscillator, breadboard, and soldered circuit are as followed.